In this video, we will learn how to use sheets to plot data, and how to have sheets try to fit a line or parabola onto your data. The things we learn here will also mostly apply to Excel, though the interface there is a bit different. We start with data collected from an experiment, where a ball was dropped, and its position over time was recorded. So we want to plot this data where the horizontal axis will be the time, and the vertical axis will be the position. To do this, we will click here and drag the mouse over all the data, including the column titles. Now we have selected all the data. Next, we go over to the menu at the top and we click Insert. Now that the menu has popped down, we find the Chart option, and ta-da! A chart appears. So first, I'm going to drag this down to here, and I'm going to note that this plot that we have here, this chart, it's not the chart that we want. It's a bar graph of some kind, and we don't want a bar graph. We're going to want something that has a x-axis and a y-axis. So we're going to go over to chart type, and we're going to click it, and we're going to get a drop-down menu with a lot of different options. We're going to keep scrolling until we see the scatter plot option over here. This option will plot all of our data as coordinates on a coordinate plane. So we click that, and there we go. We have a bunch of dots on our chart. Note that it plotted position versus time, and not the other way around. This is because it will assume that the data column further to the left should be the horizontal axis. Now that our data is plotted, we would like to see how all the data points are connected. After all, a major goal of experimentation, and physics in general, is to understand how things are connected to each other. Very often, we are able to express those connections with an equation. Sheets has a tool called the trend line that will do its best to find the equation that connects the data together. To find the trend line option, we click any of our blue dots. That will bring us to the Series dropdown in the Customize tab of the plot. See this box here, over here? It says Trend Line. If we click it, a blue line pops up on our graph. Real quick, I'm just going to change the color of the trend line to red because I like the way that looks. Now, if we look at the red line, we can see that it kind of follows the data, but it really is missing the points by a lot. In fact, it seems to be the wrong shape even. This is because the trend line option is set to linear, as you can see here in the type option. Sheets is looking at the data and trying to make a line that fits the data as well as possible. However, since the data is not in the shape of a line, the fit looks bad. As a result, we know that we need to fit the data to some other shape. So let's click the type field and look at our options. See, Sheets can try to fit the data to a whole bunch of different shapes. For our purposes though, we are going to try to fit the data to a parabola. A parabola is a second-order polynomial, so we will click the polynomial option. Lucky for us, the default setting of polynomial is of degree 2, which means second order, which means a parabola. Now if you look, the red line fits the data set as a whole very nicely. Sure, some of the points are a bit off the parabola, but they are very close. And when we take real data, very close is often as good as we can reasonably expect. Now, it's nice that we have a pretty parabola, but it would be great if we could see the equation that generates the parabola. So to do that, we are going to click the Label drop-down menu and find the Use Equation option. And great, now an equation has popped up over here on the side of the chart. This equation provides the relationship that connects our dots. One last thing. There is a little box over here titled Show R Squared. If we click it, we have something pop up next to our equation over here. It says R squared equals 0.998. R squared is a measure of how well the data fits. The closer we are to 1, the better. 0.998 is actually pretty good. There aren't set rules for what's too low, but I would say that anything below 0.99 is not so good. If we change the type of trend line back to linear, the R squared value is now 0.955, which is really quite bad. And that's it. Thanks for watching.